Okay, so we're going to be looking at graphing in this course. Now, this course is broken into, in the first half of this course, it's going to be dedicated to graphing linear functions. The second half is going to be dedicated to graphing quadratic functions. Okay. Now, this course is going to commence live starting Monday, and it's going to go through its modules, take a week off, and then it's going to go again for those who wanted to get in but did not get in. So what you want to do is you want to contact us to find out where we are in the course when the next course starts, and make sure you register. This course is going to be available on Facebook. Some of it is also going to be available on IG. All right, get more information through WhatsApp, Facebook, or IG. Okay. So the course has 7 modules. And the first module is going to talk about the objectives and the introduction. That's this module right here, this first module. And the second module is seen here is going to talk about the single variable equations and finding C. And then we're going to move on to the slope and the equation of the line. And we're going to move on to working with the actual graphs, sketching them. We're going to talk about parallel and perpendicular lines. We're going to learn how to find the midpoint and the distance of line segments. It's going to end with an assessment. Okay. So let's get started. In terms of our introduction, here are some things that you need to know. You need to have an idea of what single variable equations, what are those and how do we solve them? And in our second module, we're going to take a look at a couple of those, and you're going to have to go back if it needs some refreshment. All right. You're going to have some knowledge of Cartesian planes, the XY axis, just some general knowledge of negative numbers. You will recall that in terms of the XY plane, you do work with negative numbers there. And you're going to have an idea of scaling. Minimal scale knowledge is going to be okay, and we're going to get to that. You will need a notebook, of course, graph paper, ruler, pen or pencil, calculator for this course. Let's talk about the objectives. What do I mean by objectives? At the end of this course, these are some of the things that you'll be able to do, right? So you'll be able to find the equation of a line given 2 points. So if I say, for example, here are 2 points, and I say, I give you 2, I give you 4. And I give you, let's say 4 and 8, just for argument's sake. These are 2 points, okay? Now, all we need are 2 points to form a line. That's all we need. So if I connect these 2 points right here, I have formed a line. That line has an equation. Given this information right here, I can find the equation of that line. And by I mean you at the end of this course. So that's one of our objectives. You can also be expected to look at a sketch, right? So we're given a sketch, and you're given a line, and you're given 2 points on this line, any 2 points on this line. Let's say you're given this point right here and this point right here, and you know the values of these points. It'll be very similar to this where we have 2 points, and so you should be able to find the equation of that line at the end of this course. You should be able to find the intercepts. And this is a good time for me to explain to you what the intercepts are. So our intercepts in this example will be right here and right here. So remember, this is your y-axis and this is your x-axis, okay? Right here, at this point right here, this line crosses your y-axis. Hence, we have a y-intercept, okay? The y-intercept. you're going to learn that in this course, your y-intercept is your C value. We'll talk more about that, okay, as we move on. But you also realize that this intersects the x-axis right here. And so this is the X-intercept. So you're going to learn those as well, okay? We have a line right here. And let's say I ask a question, is 2, 5 on this line? You're going to be able to answer that question. By the time you're done with this course, you're going to be able to tell if any given point is on a particular line and so forth, okay? If I give you the equation of a line, if you are given the equation of a line, y is equal to 3x plus 4 for argument's sake, you will be able to sketch this graph. Sketch this graph. Produce a sketch, which would be a true representation of this graph. Okay, you're going to be able to do that. You're going to be able to decipher parallel and perpendicular line which passes to a point. So you have an equation, and if I say to you, listen, I want you to find me a perpendicular line which passes to 4 and let's say 7. A line that is perpendicular to this one, but passes to this point. If such a line exists, you will be able to find it. If such a line doesn't exist, you'll be able to determine that such a line does not exist. You will also be able to determine the midpoint and the length of a line segment. So for example, if I give you a line and I say that this line goes from here to here, so I say that a point is here and one point is here, this then becomes a line segment. So I can call this A and I could call this B. You'll be able to determine the midpoint of this line. You'll also be able to determine the length of this line, okay? You'll be able to do those things, all right? So moving on, those are examples of the things that you'll be able to do at the end of this course. Let's then look at a couple examples and just take a look at what we know so far, what we should know. So if I have y is equal to 2, x minus 4. One of the things that you will be able to do is you're going to be able to determine that this right here, that right there is your m. That's your gradient. And another name for gradient, slope. That's your slope. And we can tell a lot about the nature of the slope by taking a look at that number. What do I mean by that? That number is a positive number. M is equal to 2. 2 is a positive number. What does that mean? Okay. Let's take a look at a diagram. So here we are. We have a diagram. I'm going to produce 2 lines on this diagram. I'm going to produce one line that looks like that, and I'm going to produce another line that looks like this. All right. And then we're going to identify the nature of these things, right? So this line, so this is y. And this is x. Okay, and this is one line, and this is another line. All right. If you notice, if we look at, let's call this line y1, so we can make reference to them and know what we're talking about. Y1 grows upwards. What do I mean by that? I'm going to write what I said here. Y1 grows upwards. What do I mean by that? I mean moving to the right, moving from left to right, moving towards positive infinity for x. See? So this is negative something, and it's moving when it becomes positive, then a larger positive number, then a larger positive number, and so forth. So it's moving to the right, moving towards positive infinity. As it goes that way, this graph is going upwards. See? If it didn't stop here, we keep going like that, keep going like that. So x keeps getting bigger. So this is growing upwards, right? Now, conversely, if you look at y2, this grows downwards. See, as we come from negative to positive, as we get larger, as you move from left to right, this is going this way and this way and this way. Now, as I do this, follow the values for x. It keeps getting larger and larger and larger. But this line keeps going down, 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 down. This is all because of the nature of the gradient, okay? So when I have a positive gradient, and I'm gonna just put a plus and then an apostrophe VE, positive gradient, then the line grows upwards. And when I have a negative gradient, remember, M is my gradient, M is my slope, the line goes downwards. So your first lesson, your official first lesson is to be able to identify the nature of a slope. So then if I came over here, right, and I said, okay, let's do some identification here, right? Let's do a little multiple choice here. So I'm going to give you, let's say, 4 little mini graphs to figure out. 4 little mini graphs to figure out. And all I want you to figure out here is the nature of the line, the nature of the slope because of the line. All right, so let's just do this the right way. Then I'm going to go ahead and put in these sketches. So this is y, this is x, 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 and let's go ahead and get these in there. All right, so I have one that looks like that. And I'm going to have one that looks like this. And I'm going to have one that looks like this. And then I'm going to have one that looks like this. All right, now what I'm going to do is I'm just going to label these. So I'm going to call this A. I'm going to call this A. I'm going to call this B. I'm going to call this C, and I'm going to call this D. So I have 4 of them, right? And we're going to look over all 4 of these. And all we're going to do is we're going to identify them by negative or positive slope. Negative or positive slope. So as we look at the first one, right? This thing is clearly going downwards. So someone might say, well, if we start from here, this is going up. We don't start from here. What I'm teaching you is that I want you to read from left to right, going towards positive infinity. So we're always going to be looking in this direction, always, regardless of what the diagram is. As far as we're concerned, we're moving from left to right. Is it going up or is it going down? Well, this is going down. Because this is going down, the slope is negative. M is negative. I can tell that automatically. I'm gonna give you a half a minute to figure out B, C, and D, and I'll come in and I'll give it to you. So for B, again, we're moving this direction. This is how we're focused right now, right? We're moving in this direction, and we're thinking about the slope. If we're moving in this direction, then this thing is going upwards. So this thing is positive. This thing is positive. The slope is positive. This is in reference to the slope. Okay. Similar again with this one, this is going upwards again. Even though it's not going steep upwards, it's going upwards. So M is positive. And again, this is the direction we want to go. So again, M is positive. Okay. So let's talk some more about that. Let's talk some more about that. Again, we're still focusing on the nature of the slope, right? What if I had y is equal to negative 3x plus 2. I had y is equal to 4 over 3x minus 2. I have y is equal to x, and I have y is equal to negative 0.05x plus 4. Now, these are 4 multiple choice that I have. Okay, now here's my question. My question is, which of the following goes downwards? So each of these represent a graph. Each of these represent a straight line graph. Which of the following goes downwards? And again, just to be clear on what we mean by go downwards, right? What we're doing is we're saying, let's say this is your X and Y. We're gonna look at this direction, left to right, towards positive infinity, right? If this thing is going upwards, the general direction will be something like that. Doesn't matter if it's like that or like that, even like that. As long as we move to the right, this thing is going upwards, right? And if it's going downwards, then it's going to look something like this. Okay, right? So that's the general idea, right? So let's get back to our question. Let's get back to our question. Our question is asking, let's look at A. Does this graph go upwards or downwards? Well, how do we know that? You will recall that we just looked at some of these examples, and we can tell if M is negative, what happens? If M is positive, what happens? Having said that, we have to take a look at the M's. So in all of these, we have to take a look at the M's. So the M is right here. It is that coefficient of the X variable. Right here, this is M. Right here, we don't see something, but something is there, isn't it? This is a 1. It's a silent 1, but it's a 1. More importantly, it's a positive 1. Right here, we have negative 0.05. So this is negative, so I can tell right away that this line is going to go downwards because M is negative. And by downwards, it doesn't mean directly straight down south. It just means it could go this way. It could be going that way. These are all representations of downwards on your graph. Okay? All right. This is positive, so this is going upwards. This is positive, so this is going upwards. And this is negative, so this is going downwards. Okay? Now, what you're also going to learn as we move farther into this is the steepness. The steepness. M, your slope. Another name for that is your gradient. Tells of the rate of growth. Or if you want to put it in layman terms, how steep the mountain is. And what do I mean by mountain? Think about a set of stairs. We've all seen some stairs. Some stairs come like this. And some stairs come like this. Which one of these would you rather climb? This one goes more like this. They're both going up. This one goes more steep. This is more steep, if you will. More steep versus steep. This is still steep. You're still climbing upwards, right? But this is more steep. It takes up more energy. Not that that matters in math. However, the slope of these stairs are different. And in explaining the slope of these stairs, this one over here is more steep. If we were able to find M for these, you would find that if this was referred to as M1, and this was referred to as M2, M2 would be greater than M1 because this is more steep. So the larger M is, the more steep your line is going to be. So this is all just talking about the nature. This is not how we get the value of M, right? We will make reference to that as we move further in our modules, how to actually find these values, okay? But for now, what we're doing is we're just talking about the nature of the growth, okay? All we're doing is talking about the nature of the growth so far. Very good, very good. Let's go back to an example that we looked at earlier. So I have something that looks like this, okay? And I already mentioned, this is your y-axis, this is your x. Again, knowledge of the Cartesian plane is important. We have to be able to at least recognize these values. You have to at least recognize on the left-hand side of the x-axis is where we have negative numbers. And the below the x-axis is where we have the negative numbers for the y-axis, right? So let's just say for argument's sake, I had a situation that looked like this. I have, let's say, this is my scale. Remember I mentioned you have to have knowledge of scale. Now this is just a sketch. This is just a sketch. This isn't exact. This isn't accurate. But notice I'm trying to make the distances between these numbers pretty much the same as much as possible, right? Trying to use the same scale. So let's say this is 1, let's say this is 2, let's say this is 3, 4, 5, okay? And this is 1, and this is 2, and this is 3, and 4, all right? So let's say now what we have here is a situation like this. This thing passes to 2 over there and 3 over there. So let's talk about this for a second. Before we even get down to what I'm showing you here, let's quickly take advantage of this opportunity to make a couple things clear. Here's what we know. We know this graph is going downwards. We know that. We know this graph is going downwards. We can see that. Hence, M is what, guys? M is negative. M is negative. We know that. This is equal to Y is equal to negative something times X plus C. We know that. We know that M has to be negative, and we should be tapping ourselves on our shoulder because we learned, if nothing else today, we've learned the nature of the gradient. Awesome. Good job. But that's not what we're doing in this slide. In this slide, what we're doing is we're going to identify our intercepts. All right. So right here, this thing intercepts the y-axis. It intercepts the x-axis. Now let's pay close attention to that. What is this point right here? Remember, the coordinate system is an XY system, right? Meaning every point has an X value and a Y value, right? So what is this point right here? this point right here. What is that point? What is that point? The X value here is 0. So this is 0. And the Y value is 2. This is 0, 2. Okay. And then now we're also looking at this point because this is where it crosses the X-axis. This is the X-intercept, right? So what is that? Well, the X value is 3. And the Y value is at 0. Okay. So let's identify this. This is your Y-intercept. Okay. This is your X-intercept. We're going to be working a whole lot with this bad boy right here. A whole lot with this. Okay. Right here. Your Y-intercept is going to be our baby. We're going to get into that in our second module. All right. We're going to be working a lot with your Y-intercept. Okay. But for now, I'm just showing you how we go about finding the intercepts. If you were looking for a definition, then what is your Y-intercept? It is the point where your line crosses the Y-axis, or it intercepts it. And your X-intercept is the point where your line crosses the X-intercept. So it doesn't matter what problem you're given. You can identify what your Y-intercept is or your X-intercept is. Now, let's say you weren't given these numbers here. How would you find it? We'll get into some of that in the module 2. For now, this is where we'll stop for today. Normally, I would give you some assignment, but given this is our first session, there's not much to assign to you, but I will ask you to go ahead and review what we did today. You should have some notes. Go for it.